So in this video, we will be talking about the definition and calculation of molar mass. So first, it's important to understand what molar mass is. To determine the molar mass, you have to find the mass of the substance divided by the moles of that same substance. So in essence, you're taking the grams of that substance and dividing it by the moles of the substance. So our example is when the element A is burned in excess of oxygen, the oxide A2O3 is formed. 0.5386 grams of element A is treated with oxygen and 0.711 grams of A2O3 are formed. Identify element A. So because it asks us to identify element A, we have to find the molar mass of element A. So we take what we're given, 0.5386 grams of A, and plug it into our molar mass equation. In order to find the molar mass of A, we have to know the moles, which we don't know, so that's what we're trying to find. So to start off this problem, we should write a balanced equation. So once you balance all of your coefficients, you will end up having 4 here, 3 here, and a 2 here. Now we need to write down what we know. So we already know that we have 0.386 grams of A. We also know that we have 0.711 grams of A2O3. So we need to use what we know to solve for the unknown. The only element in this equation where we definitely know its molar mass is O2. So we need to use a mass of O2 to perform a mole ratio. So because of conservation of mass, if we subtract this value from this value, we'll get the grams of O2. So we take 0.711 and subtract 0.5386, and we get 0.1724 grams of O2. So now we can do our dimensional analysis. We'll have 0.1724 grams of O2, and we need to convert this to moles of O2. So in 1 mole of O2, there's 32 grams. So now we need to do our mole ratio from O2 to O, because we will be using A2O3 to find the moles of A. So in 1 mole of O2, there's 2 moles of O. And now we need a mole ratio between O and A. So according to this compound, we have 3 moles of O and 2 moles of A. So once we solve this on our calculator, this should end up giving us moles of A. So we take 0.1724 divided by 32 times 2 times 2 and divide by 3. And we get 0.00718 about moles of A. So now we have our unknown. So we plug this into the molar mass equation. So we have that many grams of A, and now we know this unknown is 0.00718 moles of A. And as you can see, our units will end up being in grams per mole of A, which these units are molar mass, which will allow us to identify what A is. So now we just divide and we get 75.0. And if you look for an element with a molar mass of 75 grams per mole on the periodic table, you will find that it's arsenic.